Hello everyone, I'm Akanksha and today I will be talking about cloud price analysis. So as we are all aware that a lot of companies these days have cloud needs for which they have different vendors in the industry, and these vendors like AWS, Azure, Google Cloud, they all keep changing their prices from time to time. So, for a user to know how these prices are changing or how they could come up with a different instance or a different product they could be using to save some cost, it will be great to have a cost optimization model that allows the user to do so. So, looking at the data set for this project, we'll be using AWS data set, and this is how their UI looks like, which has the information about all the products and different instances they have to offer. So on the left side, we have these instance categories, which are also called instance families. And these are all the instance types and different SKUs that are offered from AWS. So looks pretty tedious to go through each one of them since there's a lot of text over here. So to reduce all of that trouble, we'll be downloading the data set and looking into that. So to download the data set, we will be looking into this API that is offered from AWS again. So we download the offer file from here and look into the same in a JupyterHub environment. To get into JupyterHub, we'll be going to operate first, and we'll be using Mass Open Cloud MOC for that. So once we're here, we will launch the JupyterHub, and I've already spawned a notebook over here for cloud price analysis. So which when you're spawning, make sure you spawn the latest version of the notebook. And here we can see this is today's one. So we go to notebooks, experimental, and then there are two notebooks. So we'll be looking into the EDA notebook first, which I have here. So I've already imported the libraries and downloaded the dataset because the dataset's a little bigger, so it takes a while to get loaded. Now looking into the data, these are some features and this is how it looks like. This is the head of the data frame, and we can see there's a lot of redundant information on our screen right now, and we can see that the products category looks like something that could have more information because everything else doesn't have a lot of information. Moving forward, we'll run and see the shape of the data set. We know it's 7 columns and there are a lot of rows over here. So what we'll do is we'll make a separate data frame for just products, and we'll move forward. And I've created a small sample for 2400 values only because there are a lot of values and it gets difficult and tedious to do a lot of calculations on a bigger data set. And moving forward, we try to see what this product data frame has for us. Here we can see that there's product family, which is again a constant, and then service codes also the same for everyone because we're looking into EC2 service. And for locations, we have various locations, etc., etc. So on and so forth. We have a lot of attributes that we'll be looking into, and attributes is what decides what product we're going to choose because depending on our needs, we choose a particular attribute and further decide which product we are looking for. So further, we try to find out different unique elements inside these attributes. So first, we start off with product family and we see these are the different product families that are available. Then we see what all attributes we have. So this is the entire set of attributes. There are around like 60 something attributes we have here. And then make a dictionary of it. Moving forward, we try to find out various unique elements and see which attribute is more important for us or not. So we see location. So yeah, it's definitely a very important attribute for us because depending on which location we belong to, we will choose a service. So yes, it is important. And then something like location type doesn't look so important to me because it has only one value, AWS region. Like what information you can get from this, not much. So similarly, we can find for current generation, instance families, vCPUs, what all different values we have, and so on and so forth. So here, Small example of how you could try out any attribute in this notebook. Just replace the value after attributes, and if I want to try out, say, GPU, I can say, all right, so I have these different values. So some people use only one GPU, 8, 4, 16, 2. So depending on your need, you can choose an attribute according to your needs. So if you do not need 16 GPUs, you need not pay for it. And similarly for, I will say, operating system, uh, whichever machine you have and whichever OS you want to use, you can choose an instance accordingly. And yeah, so that's pretty much about this notebook. And then moving forward, we have another notebook where we have plotted, we have done an in-depth analysis, and we have some graphs on how these values are distributed. So right now we have instance type, which is one of the most important attribute over here, because um, these hold a lot of importance in selecting a particular SKU. So we have made a graph over here, and we can see, we see that these few ones are not that popular, and then there's a C category which looks pretty okay, popular. Then there's C5A, which is again not very popular amongst the users, and like they don't have enough number of instances belonging to this category. And there are a lot of instance types over here. For this particular subset of the data set, there are 341 values. And similarly for storage also, we have a graph over here. We can see what all options in storage they have. So some of them are like popular, like we can see that this value is surprisingly used by a lot of users according to their needs, and so on and so forth. So that's pretty much about my presentation on cloud price analysis. To know more and contribute, you can go to our website on Upgrade First, and there's an option to contribute to this page. This is going to redirect you to our GitHub repository where you can create issues and contribute to our code. Thank you.